Hi, I am Lucky Basu, Assistant Professor in the Department of Electrical Engineering in Mollabhum Institute of Technology. Today we will be going through a very interesting technology, that is the smart grid technology. Let us move on to the topic. Now, what is a smart grid? A smart grid is an electricity network enabling a two-way flow of electricity and data with digital communications technology, enabling to detect, react and proact to changes in usage and multiple issues. Smart grid have self-healing capabilities and enable electricity customers to become active participants. Now, the next question which comes to our mind is why we are going for grid modernization. Actually, smart grids have self-healing capabilities which enable them to detect automatically and respond to grid problems and to ensure quick recovery after disturbances. The benefits of a smart grid also include improved efficiency and reliability of the electricity supply, integration of more renewable energy into existing network, supporting the development of electric vehicles at scale, new solutions for customers to optimize their electricity consumption and reduction of carbon emissions. According to the electrical utilities, a smart grid employs innovative products and services together with intelligent monitoring, control, communication and self-healing technologies to better facilitate the connection and operation of generators of all sizes and technology. It also allows consumers to play a part in optimizing the operation of the system. According to the electrical utilities, it also provides consumers with greater information and options for how they use their supply. It significantly reduces the environmental impact of the whole electricity supply system. It also maintains or even improves the existing high levels of system reliability, quality and security of supply. And it also helps in maintaining and improving the existing services efficiently. Now, the next important thing is the advanced metering infrastructure. AMI or advanced metering infrastructure is a collective term to describe the whole infrastructure from smart meters to two-way communication network to control center equipment and all the applications that enable the gathering and transfer of energy usage information in near real time. Actually, the AMI makes two-way communication with customers possible and it is the backbone of the smart grid. The objectives of AMI can be remote meter reading or for error-free data network problem identification, load profiling, energy audit and partial load curtailment in place of load shedding. Now, let us move on to the building blocks of AMI. AMI is comprised of various hardware and software components, all of which play an important role in measuring energy consumption and transmitting information about energy. Right? So, the overarching technological components of AMI include smart meters. Smart meters are advanced meter devices having the capacity to collect information about energy, water and gas usage at various intervals and transmitting the data through fixed communication networks to utility, as well as receiving information like pricing signals from utility and conveying it to the consumers. Next in the line comes the communication network. The advanced communication network, which supports two-way communication, enables information from smart meters to utility companies and vice versa. Next in the line is the Meter Data Acquisition System or MDAS. Software application on the control center hardware and the DCUs, that is the data concentrator unit, is used to acquire data from the meters via communication network and send it to the MDMS. Next in the line is the meter data management system, that is MDMS. It is the host system which receives, stores and analyzes the meter information. Now the metering architecture of the smart grid. Now smart metering is the main initiative for fulfilling the objectives of the smart grid. Smart grid solve critical problems like balancing of renewable, customer operations, peak management and many more. Undeniably, smart metering reduces the commercial losses, monitoring of energy theft detection, enhancement in grid reliability and leads to better revenue as well as tariff management. Further, it introduces innovative tariff structures and dispatches accurate bills based on meter data, thus reducing the annoyance of the customer and increasing the improvement of customer loyalty. It will encourage customers to change behavior and optimize energy consumption even by generating electricity at their own premises and vend it back to the grid. So, smart metering architecture plays a vital role in achieving the objectives of the smart grid. We have already discussed the benefits of the smart grid, which actually optimizes the asset utilization and self-healing abilities of the smart grid, improved reliability and efficiency, reduced greenhouse gases emission and increased energy security and power quality. Now let us move on to the next slide, which is a comparative study between the traditional grid and smart grid. Now let us move on to the comparative study. The existing grid is mostly electromechanical, whereas the smart grid is digital in nature. The existing grid has only one-way communication. On the other hand, smart grid has a two-way communication infrastructure. The existing grid is mostly centralized generation, whereas the smart grid has a distributed generation. Sensors are not widely used in the traditional grid, but in the smart grid, sensors are used widely. The existing grid has a lack of monitoring issues. Only manual monitoring is possible, whereas in smart grid, the digital self-monitoring provision is there. In the existing grid, failures and blackouts are common, whereas in smart grid, because of the adaptive and intelligent control, the failures and blackouts are less energy efficient. The smart grid is not less energy efficient, that is, it is energy efficient, whereas the existing grid is less energy efficient. In the traditional grid, usually it is not possible to integrate the renewable energy resources, whereas in the smart grid it is possible to integrate large-scale renewable energies. In the existing grid or the traditional grid, the customers have less scope to modify usage. Now, in the smart grid, customers can check uses and modify accordingly. Now, let us move on to the disadvantages of smart grid. High cost is incurred due to the replacement of analog meters by more sophisticated electronic meter in the smart grid. There is a lack of regulatory norms for standards for technologies in smart grid, and lack of official technology documentation is also there. So this includes the disadvantages of the smart grid. Also, there are some security issues. So, this was a short overview of the smart grid technology. Hope you liked it. Thank you.